Hello students, in this lecture let us learn about Cayley-Hamilton theorem and using Cayley-Hamilton theorem how to find the inverse of a matrix. Cayley-Hamilton theorem states that every square matrix satisfies its own characteristic equation. So if A is a given matrix, if it is a square matrix, then that A will satisfy its own characteristic equation. So this is the statement of Cayley-Hamilton theorem. So here the question is verify Cayley-Hamilton theorem and hence find the inverse of the matrix A. So a matrix A is given and they have asked us to verify the Cayley-Hamilton theorem and hence to find the inverse of the matrix. Now in order to verify the Cayley-Hamilton theorem, first we have to check whether the given matrix is a square matrix. Here the number of rows is 3 and the number of columns is also 3. So it is a 3 cross 3 matrix. So A is a square matrix. Now we have to show that it satisfies its own characteristic equation. So for this matrix A, first we have to find the characteristic equation. And in that characteristic equation, at the place of lambda, we have to replace it by A. And we have to check whether that equation satisfies or not. Now, first we will consider the matrix A. So the first step will be, step 1 will be to find the characteristic equation. To find the characteristic, I will write in short, characteristic equation of the matrix A. We know that the characteristic equation is given by lambda cube, because this is a 3 by 3 matrix. We have to start with lambda cube minus s1 lambda square plus s2 lambda minus s3 is equal to 0. Now we have to evaluate s1, s2 and s3, where s1 is equal to sum of the diagonal elements. So sum of the diagonal elements of A. So of the matrix A. So what are the diagonal elements of A? 3, 3, 4. So we have to add 3, 3 and 4. And so finally we get it to be 10. So therefore our S1 is equal to 10 for this matrix. Let us find S2. S2 is equal to what? Sum of the minors. Sum of the minors of the diagonal elements of A. Of the diagonal elements of A. So what are the minors? So first we have to find the minors of the diagonal elements and we have to add them. So first we have to find the minor of the element 3, the first diagonal element. So we have to block the corresponding row and column and we have to consider the matrix which is left out, that is 3, 1, 5, 4, and we have to write the determinant of that. So 3, 1, 5, 4 plus the minor of the diagonal element 3. So the minor of the diagonal element 3 will be the determinant value of 3, 2, 2, 4. So 3, 2, 2, 4 and then plus the determinant value of the minor of the diagonal element 4. So we have to block the corresponding row and the column, that is like this. So the determinant of 3, 1, 4, 3. So 3, 1, 4, 3. So this will give us the sum of the minor of the diagonal elements. So let us find the determinant of this first. So it will be 12 minus 5 ones are 5 plus 3 into 4. So 12 minus 2 times is 4 plus 3 times is 9 minus 4 1 times is 4. And so that is equal to, it will be 7 plus this is 8 and then here 9 minus 4, so plus 5. So that is equal to, when we add up all this, we get 20. So S2 is equal to 20. Now we have to find S3. S3 is the determinant of the matrix A. So S3 is equal to the determinant of A. So the determinant of A will be, let's find the determinant of this. So when we block 3, so first we have to consider this element. So 3 multiplied with this. So it will be 3 multiplied with 3, 1, 5, 4. And then first we have written plus, so next will be minus. The second we can consider this element, and so this element if we block, we get 4, 1, 2, 4. So it will be 1 multiplied with 4, 1, 2, 4. And then after plus here it will, after minus here it will be plus. And the last element that we can consider is 2. So 2 multiplied with the determinant value of 4, 3, 2, 5. So it is 2 multiplied with 4, 3, 2, 5. And so that is equal to 3 multiplied with 4 3 times is 12, minus 5 ones are 5, minus 1 multiplied with 4 fours are 16, minus 2 ones are 2, plus 2 multiplied with 4 fives are 20, minus 3 twos are 6. And so that is equal to 3 multiplied with 7 minus 1, 16 minus 2 is 14, and then plus 2, 20 minus 6 is also 14. And so finally when we simplify this, we get 7 3 times is 21, minus 14, and then plus 14 2 times is 8, so 28. So that is equal to, when we simplify this, we get 35. So our S3 is equal to 35. Now we have found S1, S2 and S3. Now we have to take all this and substitute in this, and so we will be getting, this characteristic equation will be lambda cube minus S1 is 10. So 10 lambda squared plus S2 is 20, so 20 lambda, and then S3 is 35, so minus 35 equal to 0. So this is the characteristic equation. So I have taken and written the characteristic equation here. Now second step. So step 2 will be, we have to replace lambda by a. So when we replace lambda by a, we get a cube minus 10a squared plus 20a minus 35. Because we are going to verify the Cayley-Hamilton theorem, and the theorem states that every square matrix satisfies its own characteristic equation. So this is the characteristic equation of the square matrix A. Now we have to prove that it satisfies this equation. So if we want to prove that it satisfies, we have to replace it at the place of lambda, and we should check whether this equation is equal to 0 or not. So that is what we have to check actually. So what we have to do is, we have to consider the left hand side, and we have to prove that while simplifying the left hand side, we get a null matrix. That is, we get it to be 0. So that is what we have to prove. So we shall consider the left hand side first. So in the left hand side, here we have to actually replace this, like we have to write it in this way. So in the left hand side, at the constant place, we should write it as 10a squared plus 20a and minus 35i, because I is an identity matrix with entries 1 0 0 0 1 0 0 0 1. So when it is a constant, we have to write the matrix I here, because anyway if we multiply 35 with the identity matrix, we will be getting the same value. So we have to prove that this is equal to 0. So in order to prove this, first we have to prove. So to prove this is equal to 0, so in order to prove this, we shall first solve this, where I we know, the matrix A also we have from the question. Now the matrix A square we have to calculate. So A squared will be equal to the matrix A multiplied with A, and so that will be equal to, first we shall write the matrix A. So 3 1 2 4 3 1 2 5 4. Now this matrix has to be multiplied with itself. So 3 1 2 4 3 1 2 5 4. So we have to multiply matrix A and A to get the matrix A square, and so that will be equal to, so we have to multiply two matrices, that is 3 multiplied with 3 is 9, and then plus 1 into 4, so 4, plus 2 into 2, which is also 4, and then 3 into 1, so 3, plus 1 into 3, so 3, plus 2 into 5, so 10, and then 3 into 2, which is 6, plus 1 into 1 is 1, plus 2 into 4 is 8. So similarly, second row and first column. So 4 3 times is 12, plus 3 4 times is 12, plus 1 into 2 is 2. And then 4 ones are 4, plus 3 3 times is 9, plus 1 into 5 is 5. And then 4 2 times is 8, plus 4 3 times is 1, plus 1 into 4 is 4. And then the last row with all the columns. So 3 times is 6, plus 5 4 times is 20, plus 4 2 times is 8. And here 2 1 times is 2, plus 5 3 times is 15, plus 4 5 times is 20. And then 2 2 times is 4, plus 5 1 times is 5, plus 4 4 times is 16. So now we have to simplify this, which will be equal to, and here it is 3, because it is 4 2 times is 8, 3 1 times is 3, and 1 4 times is 4. So kindly make that correction, and then later when we have to add everything. So when we add this, we get 17, and then here 16, then this is 15, and when we add this we get 26, and this is 18, and on adding this it is 15 again, and then here it is 34, this is 37, and then when we add this it is 25. So this is our matrix A square. So now we have calculated A square. The only thing left out is we have to calculate A cube. So A cube is what? The matrix A cube will be equal to A squared multiplied with A. A squared just now we have found 16, 15, 26, 18, 15, 34, 37, 25. And the matrix A is the given matrix 3, 1, 2, and then 4, 3, 1, 2, 5, 4. Now we shall multiply these two. So on multiplication, so I have shown that multiplication here. It is same as the multiplication of two matrices. So after simplifying this, finally we get 8 cube to be equal to, this is 145, then 140, and this is 110. And the addition of this will be 180, then 155, and then this is 130, and on adding this we get 300, and here it is 270, and then 100 plus 68 plus 37, which is 205. So this is the matrix A cube. So we have obtained the matrix A, and we have obtained the matrix A cube. Now we can substitute A cube, A squared, A and I in this equation, and we can check whether we are getting this left hand side to be equal to 0. So now we are considering the LHS here. So A cube, so this is the matrix A cube. minus 10a square, so matrix A squared, plus 2a, so 2a, minus 35i, so minus 35, the matrix I is the identity matrix this. Now we have to simplify this and we have to check whether we are getting 0. So it is 145 minus 10 into 17, so minus 170, plus 2 into 3, plus 3 2 times is 6, minus 35 into 1, so 35. So this is the first element. And then 140, second element, 140 minus 160, okay, and then we have plus 2 into 1, so plus 2, minus 35 into 0 is 0. Then the third element will be 110, okay, this minus 10 into 15, so minus 150, plus 2 into 2, so 2 times is 4, minus 35 into 0, so 0. So like that we will do for the remaining rows. And here it is 20 actually. So if it is 20, so 20 into 3, so 3 2 times is 6, so this will be 60, and this will be 20 into 1, so 20, 20 into 2, so it will be 40 actually. So similarly we have to do the other rows and columns, and so after doing for the remaining rows we get this, where we have to simplify this again. And here in this problem, here I have written 2, actually it is 20, because here it is 20, by mistake I have given here 2, so please make that correction also. So when we take this page, it is 20a. Fine. So now after doing this, the next step will be, we observe that this is 145 plus 60 is 205, minus 170 plus 35, which is again 205. So it is actually 0 here. So similarly here it is 160 minus 160, because 140 plus 20 is 160, minus this 160, and so again it is 0. So like that if we do, we could find that when we simplify all this, we get it to be 0. So therefore we have arrived at the null matrix. So a cube minus 10a squared plus 20a minus 35i is equal to 0. So we have proved that the matrix A satisfies its own characteristic equation, and hence the Cayley-Hamilton theorem is verified. The Cayley-Hamilton theorem is verified. So next we have to find the inverse of the matrix A by using this characteristic equation. So the next step is step 3, which is to find A inverse. So we have to find the inverse of the matrix A, which is represented as A inverse like this. For this we have to consider the characteristic equation that we have obtained. So 20a minus 35i equal to 0. So this is the characteristic equation that we have obtained. So now in this, what we have to do is, we have to either pre or post multiply. So pre or post multiply by A inverse. So what I am going to do is, I am going to post multiply this equation. Suppose it is equation 1. Then I am going to post multiply equation 1 by A inverse. Post multiply means after the matrix we will multiply. Pre means before we can multiply. But anyway both will be same only. So now here I am going to post multiply. So A cube A inverse. So if you are post multiplying with one term, then all the terms we have to post multiply. So 10, okay, A square multiplied with A inverse. Then plus 20 A inverse minus 35 I A inverse equal to, right side also we have to multiply, 0 multiplied by A inverse. Now what is A cube multiplied with A inverse? So we have to add the powers. When the base is the same, we have to add the powers. So 3 minus 1 is 2. And then minus 10 A, 2 minus 1 is 1. So we can leave it like this. So A to the power 1 this means. plus 20. And what is A inverse? Always remember, when a matrix A is multiplied with its inverse, we obtain it to be I. Whether A inverse or A inverse A, whatever it is equal to I. So you have to remember this. So we get plus 20I. And then here minus 35, any matrix multiplied with the identity matrix, it will give the matrix itself. So if it is A inverse I also, we will be getting A inverse only. So this also you have to remember. So now here I is multiplied with A inverse, and so we get A inverse. And when we multiply any matrix with a null matrix, we will get the null matrix 0. And so now actually we have to find A inverse. So we can have minus 35 A inverse to the left hand side and take remaining everything to the right. So when we take it, it will become minus A squared. So this minus 10, when it comes to the right, it becomes plus 10A, and then plus 20I. When it comes to the right, it becomes minus 20I. Now we will multiply by minus throughout. So completely in order to remove this minus. So we get 35A inverse equal to, so this minus will become plus now. So A squared. Now plus will become minus. So minus 10A. So minus will become plus. So plus 20I. Now we have to find A inverse from this. We have already calculated A squared A. We have to, and we know I. We have to substitute in this place, and we have to simplify it to find A inverse. So the next step is, in this equation we are substituting A square minus 10A plus 20 in the place of I, the identity matrix. Now we have to simplify this. So it will be 17 minus 10 into 3. So that is 30. And then plus 20 into 1. So plus 20. And then 16 minus 10 into 1. So 10. And then plus 20 into 0. 0. And then 17. Then we have 15. I'm sorry. This is 15. Okay, this 15 minus 10 into 2. So minus 20. And then 20 into 0. So 0. Like this we have to do for all the values. So after doing this, we obtain this matrix, which on further simplification, 17 minus 30 plus 20 is 7. And then 16 minus 10. So we will be having 6 here. And then 15 minus 20. So minus 5. Then 26 minus 40, which will be minus 14. 18 minus 30 plus 20. So it will be 8. And then 15 minus 10, so it is 5. 34 minus 20, so it is 14. 37 minus 50, so minus 13. And then 25 minus 40 plus 20, so it will be 5. So this is what 35A inverse. But actually we have to find A inverse, and so therefore A inverse will be equal to 1 by 35 of the matrix 7, 6 minus 5 minus 14, 8, 5, and then 14 minus 13 and 5. So this is the answer. So we have found A inverse by using Cayley-Hamilton theorem. So hence this is the inverse of the given matrix. And so the steps involved in solving this problem is, first we have to find the characteristic equation. That is the first step. And the second step is we have to replace lambda by the matrix A in the characteristic equation. And then after replacing lambda by A, we have to check whether it satisfies it. If it satisfies, then we will prove that it satisfies the characteristic equation, and therefore the Cayley-Hamilton theorem will be verified. Then after that we will find the inverse of the matrix. By using the characteristic equation that we obtained, we will take it and we will pre or post multiply it by A inverse. Then after that we will be simplifying it by substituting the values, and then we will find the value of A inverse. This is how we have to do this problem. It's a very important problem in the examination point of view. Hope you have all understood it. Any doubts, kindly put it in the chat box. Thank you.